Imagine walking into a library that's very different from the ones you know. This library is like a glimpse into the future. It has an enormous collection of books, and each book has information about everything you can think of. Now, whenever you have a question in your mind, you can simply look for information about the topic you're curious about. You'll be able to quickly find the most suitable book that can give you the answers you're looking for. Doesn't that sound amazing? Think of this futuristic library as having an incredible librarian. This librarian has an extraordinary skill. They can instantly tell you the best book to read for your specific question. It's like having a personal guide to help you navigate through a vast sea of knowledge right at your fingertips. Now, here's where it gets even more fascinating. A group of researchers at Google, including people like Yuri Zemlyansky, Michiel de Jong, and Luc Vilnius, have been working on something similar to our library scenario. They've come up with an innovative idea called Memory VQ, and their goal is to completely change how AI models work. They want to not only make these models smarter, but also make them use less computer power and memory. It's like trying to make our futuristic library even more efficient and accessible. This endeavor presents a monumental challenge because the majority of AI models in existence today demand substantial memory and computational resources to function effectively. As we observe the exponential growth of data in our world, this challenge intensifies. The challenge of managing the ever-expanding amount of information is becoming more and more complex. However, the solutions offered by this research have the potential to be groundbreaking. So, how do these researchers tackle this difficult problem? They use a technique called retrieval augmented generation. Instead of trying to store all the information they need inside the AI models themselves, these models retrieve information from a vast external knowledge base when they need it. It's like having access to a huge library of information whenever required. RAG, or Retrieval Augmented Generation, is a framework used in AI to make large language models, or LLMs, like ChatGPT more reliable and accurate when answering questions or generating text. LLMs can sometimes provide inconsistent or incorrect information because they don't truly understand the meaning of words. They rely on patterns they learned during training. RAG works by connecting the LLM to an external knowledge base, which contains up-to-date and accurate information. This helps the LLM provide better responses because it can double-check its answers against real facts. It has two key benefits. RAG ensures that the LLM always has access to the most current and trustworthy facts, which helps improve the quality of its responses. Users can see where the LLM is getting its information from, making it easier to verify the accuracy of its answers. This transparency builds trust in the model's responses. In summary, RAG enhances the reliability and trustworthiness of LLM-generated responses by connecting them to external sources of knowledge, ensuring more accurate and up-to-date information. One example of a model that uses retrieval augmentation is called Lumen. Lumen is a special kind of AI model designed to make information retrieval more efficient. It does this by pre-computing token representations for the passages it retrieves, which makes the process of getting information much faster. As a result, Lumen can not only create high-quality images, videos, and speech, but also perform tasks like high-quality speaker conversion and learning phonemes without supervision very effectively. However, there's a caveat to employing memory-based methods like Lumen. They come with significantly increased storage requirements because they need to store these pre-computed representations. In essence, while these methods provide a powerful means of accessing vast amounts of information, they also demand more storage resources, which is an ongoing challenge for the development of lightweight AI models. Think of it this way. The traditional approach used by AI models is akin to carrying all the books from that massive library around with you wherever you go, instead of simply borrowing them when you need them. This method isn't particularly efficient or practical, right? It isn't very easy and doesn't make the best use of resources. This is where Memory VQ steps in as a game changer. Memory VQ is a groundbreaking method designed to alleviate the storage demands of memory-augmented models without compromising their performance. It achieves this by employing a technique called vector quantization to compress the memories, replacing the original memory vectors with compact integer codes that can be effortlessly decompressed on the fly. Think of it as converting hefty hardcover books into ebooks. They take up significantly less space while still containing all the essential information. Now, how does vector quantization work, you might wonder? Well, it's a technique that leverages a special kind of variational autoencoder called VQVAE, or Vector Quantization Variational Autoencoder, to compress data. VQVAE differs from traditional VAEs or variational autoencoders in two critical ways. First, the encoder network produces discrete codes instead of continuous ones, and second, the prior is learned dynamically rather than being static. In the context of VQVAE, it borrows concepts from the field of vector quantization, which is a method used to compress data by mapping similar vectors to the same code word in a predefined codebook. This codebook serves as a dictionary representing different vectors by assigning them specific code words. Through the use of VQVAE and memory VQ, the size of memory vectors is substantially reduced by replacing them with integer codes that correspond to the code words in the codebook. What's particularly interesting about this approach is that it enables the AI model to overcome issues related to posterior collapse, a phenomenon where latent variables become ignored when coupled with a powerful autoregressive decoder. Such issues are typically observed in the VAE framework. However, by employing discrete codes instead of continuous ones, Memory VQ provides a clever solution that enhances the model's efficiency and effectiveness. By implementing Memory VQ, the AI model gains the remarkable ability to preserve a greater wealth of information and diversity within its latent space. This is like having a more expansive and versatile toolbox at its disposal. In their practical research study, the team compared Lumen VQ to simpler models like Lumen Large and Lumen Light. They did this by testing these models on a set of tasks that required a lot of knowledge, using a benchmark called KILT. Surprisingly, Lumen VQ performed incredibly well. It achieved a compression rate of 16 times, meaning it used significantly less computing power and memory, while still delivering high-quality results. In summary, this research shows that Memory VQ, as a technique to enhance memory in AI models, is highly effective. It's a practical solution for speeding up the process of finding information when dealing with large amounts of data to retrieve. Indeed, the implications of this breakthrough are quite remarkable for AI applications. Imagine having incredibly powerful AI models that can tap into vast knowledge bases, providing accurate information and generating responses with impressive efficiency. What's truly astonishing is that these AI models can achieve this while demanding far less storage space and computational power than we previously thought necessary. This advancement opens up exciting possibilities for integrating AI into our daily lives in a much smoother way. Picture having AI capabilities right on your smartphone or other edge devices without constantly depending on remote cloud servers or expensive hardware. It's a game changer because it brings AI closer to us, making it more accessible, efficient, and integrated into our everyday tasks and interactions. This has the potential to revolutionize how we interact with technology and information, making our lives more convenient and productive. If you found this information fascinating, please show your support by giving this video a thumbs up, leaving a comment, and subscribing to the channel for more thought-provoking content.